All right, so let's start graphing some of these lines. And the first part that we're going to learn is, how to graph using our intercepts. So we got to first be able to identify the intercepts, and then if we're given the equation, can we find the x and y intercept? All right. So our objective is to identify the x and y intercepts on a graph, find the x and y intercepts from an equation, and then graph a line using the intercepts. All right. So the premise of this is that we are able to identify um, what the x and y intercept looks like when we're looking at a graph, right? So remember, this is my x-axis. It's the the horizontal axis of the Cartesian plane. And then my y-axis is the vertical one, okay? So where the line crosses this axis, that's the intercept, right? So this would be my x-intercept, and this would be my y-intercept. Now, if this graph, if this was numbered, right, I could just go down here and be like, oh, that looks like it is at 3, or I'm sorry, 2 on the x-axis, right? So I could say that this is 2, 0, but I want to be sure, so I'm gonna actually solve this equation. So when you have these equations, I suggest that you always just create a table, right? And then with these tables, it's a lot easier to find your points that satisfy the equation. All right. So if I'm looking for the x-intercept, then my y value has to be 0. Okay. So if I take this equation and substitute my y with 0, okay, I get 3x equals 6, and therefore x is going to be 2 because I divide both sides by 3. So my x-intercept is going to be 2, 0. And then for my y-intercept, now I make my x 0 so that I can figure out that intercept. So 3 times 0 minus 2y equals 6. So negative 2y equals 6. Divide both sides by negative 2, and I get y equals negative 3. And my y-intercept is now going to be 0, negative 3. All right, so we'll take a look at one more, or we'll take a look at a couple more, make sure we understand this. So again, we are identifying first where is the x and y intercept. So this would be my y intercept. Here is my x intercept, right? And so again, this graph, look at the scale, right? I can't really tell what those numbers are, but we can just create our table, x, y, and then we get our ordered pair. So for our x-intercept, we're going to give the value for y of 0. So we're going to say 0 equals negative 5 halves. I'm sorry, negative 5x plus 10. And now I just need to move one of these over. It doesn't matter which one. I'm just going to bring over the variable term. So I'm going to add 5x to both sides, and I get 5x equals 10. And now we get an x-intercept of 2, 0. Right? So my x-intercept is 2, 0. Now I'm gonna find my y-intercept. So now when I'm looking for my y-intercept, now I make my x 0. And when an equation is in slope-intercept form, your y-intercept, it's always your b, right? So what am I saying with what is your b? So in the formula, y equals mx plus b. As long as this is the form of the equation, right, where my y has a coefficient of 1, my y-intercept is always going to be whatever this value is. All right. If I had to find another point, right, I would just make it something easy like 1 for x, especially when it's in slope-intercept form. So I would say y equals negative 5 times 1 plus 10. Y equals negative 5 plus 10. Y equals positive 5. Therefore, I noted another ordered pair on this line is going to be 1, 5, right? And again, this isn't scaled, so it's hard to kind of see where that would be, right? But we would guesstimate that 1, 5 would be roughly here on that line. All right, looking at a couple more of these, right? So now this is not in slope intercept form, but I don't need it to be, especially when I'm looking for the intercepts, right? Because we know now that we can just create our table here. And for the y-intercept, we just give our x the value of 0. For the x-intercept, we just give our y the value of 0. And then we just solve the equation, right? So if I'm looking for the y-intercept, I would say 4 times 0 plus 3y equals 12. 3y equals 12. Y equals 4. So my y-intercept would be 0, 4. 0, 4. So if I go into my origin, 0 tells me not to move left or right. I go up 4. We will see that this point is 0, 4. Okay. My x-intercept, 4x plus 3 times 0 equals 12. 4x equals 12. X equals 3. So my x-intercept is going to be 3, 0. Okay. And again, my 3 tells me to go 3 to the right. My 0 tells me not to move up or down. And therefore, that would be my x-intercept at 3, 0. All right. So now we need to graph a line given this equation. And so there's a a couple of different ways we can do this. We're asked to graph it by using the intercepts. Okay, so we're going to stick with that way. So to find the intercepts, we're going to find our x and y intercept, which, by the way, anytime you have a line, right, and it's not horizontal or vertical, you're always going to have an x and a y intercept. Okay, so anytime you have a line and it's not a vertical line or a horizontal line, which we'll go over in the next video, you're always going to have both an x-intercept and a y-intercept. Okay, so to find my y-intercept, I'm going to make my x 0. So we're going to get 20 plus 3y equals 12. 3y equals 12. Y equals 4. So my y-intercept is 0, 4. So my 0 tells me not to move. I'm going to go up 4. That's where my line is going to cross the y-axis. And then to find my x-intercept, I'm going to make my y 0. So 2x plus 3 times 0 equals 12. 2x equals 12. X to 6. Okay, so my x-intercept is 6, 0. Right, so starting the origin, go 6 to the right. And now that's my x-intercept. Right, and now I can go ahead and plot this line because I have 2 points, right? So I'm basically going to go right through there. Okay, and notice the arrows on the end because, there's infinite solutions for this equation, right? So the arrows just represent that this line is not going to stop. Okay, it's not going to stop. Now, if you had to pick another point on this line, okay, you can say, well, this is a solid point on this line right here at 3, 2, right? And if I wanted to make sure that this is an actual solution to this equation, I would just plug it in. So I would just say 2 times 3 plus 3 times 2, right? Because those are my x and y coordinates according to this ordered pair that we're saying is satisfying this line is going to equal 12. 2 and 3 is 6 plus 3 and 2 is 6 equals 12. Therefore, 12 on the left equals 12 on the right. Therefore, I know that this is an ordered pair that satisfy this equation. All right, we'll look at one more. Okay. Oh, wow. Fractions. Oh, man. Here goes a fraction, right? So typically we see fractions and we start to panic a little bit, but there's no need. Okay. There's no need because there's a couple of things we can do. First off, since this equation is already in slope intercept form, we know that our y-intercept is just 0, 4, because if we just give x the value of 0, anything times 0 is 0. Right? Therefore, we already know our our y-intercept, that's going to be 0, 4. Okay, so to find our x-intercept, we're going to give y the value of 0, and we're going to say it equals 1/2 x plus 4. Okay, so now I'm going to move over the 1/2, so it becomes negative. Negative 1/2 x equals 4. Okay, and so now you're basically saying a negative half of x that equals 4. Well, you don't got to try to solve this in your head, even though you probably can because these are smaller numbers. But if you just multiply both sides by the reciprocal of the fraction, that just means flip the fraction, right? If we just flip the fraction, we're solved, right? Because negative 2 over 1 times negative 1 over 2 is just going to be 1. So our x is by itself. Okay, and then we basically, so whenever you have a fraction times a whole number, you just put the whole number over 1, right? So 4 over 1 times negative 2 over 1 is just going to give us a negative 8. So our x-intercept is going to be negative 8, 0. Right? Now, let's just say we had to find a third point for this line, which, as you see, negative 8 is going to be off the graph. So it's probably best to find another point anyway. So again, anytime we're in slope intercept form, we basically just want to give values for x so that, y can easily be found. So anytime we have a fraction, just give multiples of the denominator, right? And so since our denominator is 2, I want to give x values of, 2, 4, 6, 8, 10, or negative 2, negative 4, negative 6, right? Because then that will clear our fraction. Okay, so let's just say if x was 2, we would say y equals 1/2 of 2 plus 4. Y equals, well, half of 2 is 1 plus 4. Y equals 5, right? Therefore, 2, 5 is a point. And if we went negative, right, let's just say we said y equals 1/2, and we said x is negative 2, right, plus 4. Well, half of negative 2 is just negative 1 plus 4. And therefore y is 3. Okay, and so now we have enough points where we can plot this, even though it's asking us to plot using the intercepts, right? Because we know that this line is going to continue through this point of negative 8, 0. If we plot the 0, 4, and then we plot the positive 2, positive 5, okay, and then if we graph our line, okay, once we gonna get a line something like this, it's safe to say that this line is going to intercept the x-axis at negative 8, 0, right? So, I mean, of course, with software, right, it'll be a little more precise, but you get the picture. By us putting those arrows on the end of our line, we're saying that it's continuous, it's never going to stop. Therefore, we have an infinite number of solutions. So like any other thing, I hope this has been very helpful. But if you still have questions, don't hesitate to reach out. Talk to you shortly.